Okay, in this problem it says a highway overpass was observed to resonate as one full loop when a small earthquake shook the ground vertically at 4 hertz. The highway department put a support at the center of the overpass, anchoring it to the ground. What resonant frequency would you now expect for the overpass? Earthquakes rarely do significant shaking above 5 or 6 hertz. Did the modification do any good? Okay, so let's see our givens. Want to undo that. So our givens are, let's say F1 is equal to 4 hertz. And I think that's it. Okay, so we need to find the new frequency. Let's say F2. And then we need to know, is the modification, was it good? Did it do what we needed it to do? So let's first imagine if we think about this as a string connected at 2 ends, right? We can think about this as the smallest, or the largest wavelength that we'll have is something that looks like this. All right, so we've got half a wavelength in here, and so if we let this part here equal L, it's going to be L. And so for this first example, right, our original, we're going to have, we know that V is equal to F1 times lambda 1. And in this example, we know that lambda 1 is equal to, so lambda, remember, is the wavelength. And so in this case, my full wave would look like that. So lambda is going to equal 2L. Okay, and so in this example, when an earthquake shakes the ground, the velocity is the same. So in both cases, the velocity is the same. So let's figure out what our F1 is. In this case, we're going to have F1, just by equation, is equal to V over lambda 1, which is equal to V over 2L. And we know that then F1, they tell us in the problem, is equal to 4 hertz. So that's just telling us that V over 2L is equal to 4 hertz. So let's do the new problem here. And so we'll call this one like A, and we'll call this one B. This is the change. And so if I do the same thing and I draw my wavelength, I know that I'm going to have something that looks like that and like that. And so it's the same L, right? But here I'm going to have lambda 2 is equal to L, right? And the first case, in the A case, we have lambda is equal to 2L, and that's because, right, I extend I know I only have half a wavelength between the 2 ends of the bridge. And in this case, I have half a wavelength at half as long. So a full wavelength would be 2, adding them up, I would have full lambda, and then that's going to equal L. And so if I want to think about V, same velocity, right, because the earthquake wave is going to have the same speed, but now I'm going to have F2 times lambda 2. And so plugging that in, I'm going to have F2 is equal to V over lambda 2. Equals. And so plugging that in, I get V is equal to, or F2 is equal to V over L. So if I look at these two equations, right, if I look at this equation and look at this equation, I see that F2 is equal to F1 2 times F1, right? And that's because I need 2 F1s in order to make up F2. And so that tells me that I'm going to have F2 is equal to 2 times 4 hertz, and that's equal to 8 hertz. So F2 is equal to 8 hertz. Great. And it says in the end that earthquakes rarely do significant shaking above 5 or 6 hertz. Did the modifications do any good? And so yes, definitely it did some good, because Now the frequency is at 8 hertz, so it's above 5 or 6. So it should do a better job at protecting the bridge.